Okay, scholars, so as we mentioned before, we are starting trigonometry. So the last lesson we went and we discussed angles on the coordinate plane, and we're also going to talk about triangles. So all of this will come together by the time we end this module. This is the last module of the year, so hopefully you guys will be starting to prepare for next year in the class that you'll be in. Okay, so hopefully the Pythagorean Theorem is familiar to you guys. It may not be familiar to everyone, but that's okay because we're going to go through it. So this theorem says that a squared plus b squared is equal to c squared. It's something we hear often, but we have to make sure we know how to use it. One thing to mention is that it always works for only right triangles. So let's make sure we're only using this for right triangles. And well, what is a right triangle? A right triangle has a right angle here. So a right angle looks like a square. It has to have a 90-degree angle there. All right, so if you see this example down here, you'll also see 90 degrees here. All right, so it's good to know where that 90-degree angle is because across from that, you will always have what is called your hypotenuse. This is your hypotenuse, which is the longest side of your triangle, the hypotenuse. It's always the longest side, and it's across from your right triangle, okay? And we also want to be careful that as we're using this formula, C, since it's the longest side, this is always the hypotenuse. So let's be careful, not C squared. C is equal to the hypotenuse. And I'm just going to abbreviate it to height. All right. So let's call this side C. And A and B could be whichever side you want it to. It could be whichever side because one, we're adding it, and two, it doesn't matter, right? So once you add those two sides, you have to end up with the longest side. All right, so now that we know that the hypotenuse is C, and A and B could be either of those other sides, let's take a look at this first example. All right, we're going to take a look at this first example. So if we're going to use the A, and I like to label my triangles. So I'm going to put an A here, a B here. Notice I put an A, a B here first, and an A here. But again, those two sides, it doesn't matter. But we have to make sure that our hypotenuse is always C. That's important. So C is what we're looking for. We don't know what C is. Let's plug these numbers into our equation. So I'm going to do 3 squared. Remember, the side is the A values, and then we must actually square it after. So then I'm going to do plus 4 squared, and that is equal to the C squared, right? C, we still have to attach our exponent, and we don't know what C is. So let's begin to simplify and try and solve this. 3 squared gives us 9. 4 squared gives us 16. And C squared, we can't simplify that, so we'll leave it as C squared. 9 plus 16 is equal to 25. And now we don't want to say that this is 25. We have to take it one last step. And this last step is super important, guys. Make sure you're doing the square root so that you can figure out what C is equal to. So in this case, the C is equal to 5. All right. And so I want to mention, you guys, I want us to be careful because sometimes we are actually given a C value. So, for instance, and I'm going to say, if we have another triangle, or if the triangle was labeled like so, where the 5 was given, the question mark was down here, and the 3 was here, I want you guys to be very careful that your formula will look slightly different. Your formula will look slightly different. You will have 3 squared plus b squared is equal to the 5 squared. Why? Because the 5 is given, right? So you'll notice that if the 5 is given, we have to make sure we substitute that in for our hypotenuse, okay? This is our hypotenuse. and the side is given. So the B is what's missing. We will not always have a C missing. So sometimes you'll have an A or a B missing. So the key part here is to make sure you're substituting accurately for the missing sides. It's so important that you're substituting accurately for the missing sides, and then you can solve by working backwards.